to part 2 of the video Introduction to Functions. Let's get working! Now we are going to look at finding the domain and range from a function on a graph. Answer the following questions about the function on the graph. I'm sorry I wasn't able to take away these points. If I try to, it deletes the whole image. So, go ahead. Okay, I feel like you probably have it right now. So I'm going to change this order and go from A to C and then B and D. So, f of negative 3 equals what? So here we have the input and are looking for the output. Now remember, the input is on the x-axis. So we go to the point on the f-axis and then we see where it is in relation to the y-axis. Is it 120? Nah, it is 0. So the output is 0. Now we will go to C, a very similar question, actually, just with a different point of the line. Sorry, my voice. So f of negative 1 is right here. You have to find it. Where is it on the function? You can go up and it's here, yay! And then find it in relation to the y-axis. Go across. You find it is about in the middle, I'd say. And the middle of 1630 is 45. Oh, that was wrong. 45. And might be slightly off by 1 or 2 points, but I mean, you can barely tell. B is a slightly different question, but I bet you can get it too. The value of f at x equals 90. What is x? So essentially here, we are working in reverse. We have the output. Instead of finding the output, we have to find the input. So it is just as easy. Now we just start on the y-axis. So go here. And we can look to see how it is in relation to the x-axis. See, it's 0. I have lots of zeros here, shockingly. Now D, any x values for which the value of f at x equals 0. Now, if you're panicking right now, thinking, well, they're supposed to be similar. They're very different. The wording is only different. I wanted to use different wording so that if your math teacher presents this problem in a different way with different wording, you're not completely confused and think, what is going on here? I never learned this. But you did, but it's just sometimes it's confusing when it's said in a different way than how you initially learned. So this is the same thing as this. And you're starting with the output again, meaning you go to 0, and then you go to where the function is 0 in relation to the y-axis, which is over here. And you can see it is negative 3. Oh wow, great, a tiny equal sign. As said, writing on a computer. Okay, a function can not only be found on graphs or in equations, it can also be found in other formats, such as in word problems. Here are some examples that I took out of the textbook that I mentioned in the beginning of the last video. So basically, for the sake of referencing things, it's this. Great. So here are the examples. You can read them so that my voice doesn't eventually break from speaking so much. Let's move forward. As you can see, Oh, I thought it was using this. Oh well. Okay, so that is the input, that is the function, that's the output, You put this input into the function, and it gives you this. You put a person in a class into a function, and it gives you date of birth of that person in the class that corresponds to the person in the class. Okay, you get it. A table can also be used to represent a function. So here's the domain, in other words, x, and here's a range, in other words, y. And this input 4 has the output 2. 1 has the output 2. -3, the input has the output 5. Same here, it's just their words. Does make a difference. Now, I would like you to find, I would like you to determine which relation is a function and which is not between the two. And then find the domain and range. Okay, you won't be listening to any music anymore because my phone died. I totally forgot to charge it. Okay, so I bet you got it by now. So let me remind you. A function can only have one output for each input. For those of you that got it wrong, you'll be all having your ah moment right now. Or maybe not. I'll explain it. So, you see, the one above is a function because each input only has one output. You see? But the second one is not a function because one input has multiple outputs. Like with blue, I don't know if you see that the same as blue, it's just blue. But it has energy, it has iPhone, it has life. It has energy, life, and Vivo. Either way, doesn't matter because either way, it's not a function. It's just a relation. And now we have to determine the domain and range. Domain and range is written. I'll do A, so it's like the first one. By putting all the possible input values, an increasing value. So it's -3, 1, and 4. And there's a range. .5, and for the next one, this is a bit disorderly, I'm sorry. I think here you can just put it in whatever order. I mean, unless you're like ordering them by like how good they are, but that's all perspective. So you can just blue, apple, Samsung, or you can go apple, Samsung, blue, it doesn't matter. There you go. Okay, now another possible way is the error map. Arrow. Not error. I'm sorry, they're so similar. So this is where the domain is here, also represented as X, and the range is here. And this is Spanish, but it's basically the same. So I bet you could have figured out what it was on your own. I just thought they were, thought it was a great picture. So, determine which represents a function and why. Next, find the domain and the range. Right, you don't get any. I'm sorry, my phone died. Okay, I'm going to explain it now. I'm sorry if I'm impatient. I don't usually know how long to wait. So, the first one is not a function because, as you can see, one input has multiple outputs. Not a function, just a domain. Just a domain. I mean, just a relation. And the second one is a function. As you can see, each input only has one output. That is so great. And I'm gonna find the domain and range for just the first one because I think you're getting the hang of it. Good job. I know I can't see you, but I believe in you. So domain is all the input values on the left side, and range is all the output values, which is on the right side. To my convenience, they're all in ascending order value. But if they're not, you still gotta make sure that you put them in increasing order. Okay, a set of ordered pairs is also a possible way of expressing a function. I think we actually did one sometime. Yeah, like this, except it looks a bit different. So I'm asking you, is this a function or not? And please find the domain and range. Okay, yes it is a function because each input has one output. Input, output, input, output, input, output, input, output. Just one output for each input. Great. Okay. And for the domain, just go in increasing value. And you go all the ones that are on the x. Domain, all the inputs, x-axis. Range, outputs, y-axis. Okay, let's go to the next one. And an equation and a graph are also possible ways of representing functions, but we have already looked at those. However, for the sake of practice, let's look at them again. So here's an equation. Y equals 1/2 x, or x over 2. And as you can see, this is the output. And x is the input. Yeah. You can also, clarify that that's a function. We're doing y x equals 1/2 x, or x over 2. Doesn't matter, it's the same thing. Okay, graph. Here I have some examples of functions, not functions, and not functions again, because they're important. And I'm going to give you a smart trick to find out if a function on a graph is a function or not, because sometimes they're hard to tell. So that thing is a vertical line test, also known as a pencil test. That test received the following definition by the Pearson Algebra textbook. If it is possible for a vertical line to cross a graph more than once, then the graph is not the graph of a function. So essentially, the pencil test is a guide to show you the possible outputs for an input. If that quoted definition doesn't make sense to you, it's basically saying, like, you see the vertical line here, it's going across, right? And it's not going across once, it's going this and it's going that, but I can't. Or, oh, wait, I know. Let me take away these two. Oh no, yeah, I can't. Yeah, that's an image, so I can't do that, but, let's just imagine there's your graph here, right? And then there's your function. and then you have this line, and good purposes, and do a line here. And that's your pencil. You can use a pencil, but you can just use a vertical line. And then trying to. Oh man, this doesn't work. Either way, you basically move it across the graph. And I'm sorry for those ugly lines. And then when you move it across, you see, oh, it is a function. The line doesn't get crossed twice. Or it is not a function. Here it gets crossed twice. You see, and here too, And here, oh, it's not a function because when you go and bring it across, it gets crossed twice. Not a function. Because you see, there are two output values. It gets crossed by this output value and this output value for just one input value. It's not a function. Yeah. So, to find the input and the corresponding output, use the picture below. The graph has a function on it. However, it is not a function when there are multiple output values for one input value, such as in the two examples above, these two. And that can be tested by passing a pencil or line vertically across and seeing if a line or pencil is crossed twice when it has one input value or has stopped, just such as above. So you see, you have an input value right here. The input value is 4. And then you go up and you say, wow, it touched the line of the function. Okay, I gotta stop. And now I've got to find the output. So where is it in relation to the y-axis? And you move over and you see, oh, it's 1. So y equals 1, the output equals 1. Or you do the same thing, but backwards. That's how it works. Okay, and if I'm being... Nah, never mind. Now we will practice figuring out if a relation is a function or not. Decide whether the following examples taken from that textbook are functions or not, and why. The correspondence that assigns a person to his or her weight. The correspondence? You know what? You can read these yourself. I'm just gonna take your time by distracting you. Okay, I think you've gotten it by now. Not that fine. I'm gonna explain it. So the correspondence that assigns to a person his or her weight. Can a person, the input, have many different weights? No, they can only have one weight. So one output. So yeah, that is a function. B, the correspondence that assigns to the numbers -2, 0, 1, and 2, each number square. Do each of these numbers have multiple squares? Let's check it out. -2 squared equals 4. 0 squared equals 0. Are there different ways to square them? Not for those. Let's keep going. Okay, you get the point. So basically, for these numbers at input, there's only one square for each, one output. So yeah. C, the correspondence that assigns the best-selling author the titles of books written by that author. And you thought they were all gonna be functions? No, of course not. So a best-selling author might have many different titles of books because they wrote many different books, So no, that is not a function. D, the correspondence that assigns to a book the number of pages in the book. Are there many different possible ways and many different possible pages of numbers in a book? No. So one book one number of pages in the book. One input, one output. Yeah, it's a function. Or, well, I mean, like, if you did this thing about perspective, there are some people that count the title, some people that like the title page, and some people that don't. It's not really about that, you know? Let's consider a function represented as an equation. F at t equals 18t plus 88. F at t is the output. It is the output is the dependent variable because it depends upon t, and t is the input, the independent variable. So basically, the output is dependent on the input. Okay, find the output. Sorry, I just, gotta take this away. Yeah. So f at 2. I'll give you a moment to figure it out. Please pause the video. I'm not a patient person. Okay, let's keep going. I can take this away now. Okay, so you just basically you put the 2 in the t, and then you see what happens. So 18 times 2 is 36. 36 plus 88 is 124. So 124 is the output, and it depends upon the input too. Because if it's a different input, then it's going to be a different output. So it depends upon the input too. Try these following examples taken out of my textbook. So try these out and pause the video. So you're back, great. An area of a circle is a function. To show that, we can rewrite the formula as such. Area equals pi. I can't do this pi symbol on my computer keyboard, so I just wrote pi times r squared. So you see that the function is dependent on r, and the radius, which is r, is 4 meters. And so then the output, a at r, is, let's see, pi, put that in your calculator, times 4 meters squared. That gives you 50.2654, and so on and so forth, which we will not write because it's unnecessary. Okay. A typical adult dosage of antihistamine is 24 milligrams. Young's rule for determining the dosage size for CA. For a typical child of age is, and age A is, so the age is represented by A. So basically you substitute the age of the child in A. So this part I wrote myself because I thought it would be funner. I know a kid, Jack, who needs to take antihistamine. He is 8 years old and does not know how much to take. His parents are away and he's impatient, so he uses that equation on the box of medicine. So he uses that equation and gets his answer. But that's wrong. Where did he go wrong? Or where was his mistake? So 8 times 24 is 129, not 208. 208 is 26 times 8. And so this is what happened because he took too much medicine. So Jack had an overdoses because he took too much medicine, because he was too impatient for his parents to come home, and wanted to make them proud of being able to do math and take medicine on his own. Said his parents were sad about his death and regretted putting so much value on him being independent and good at math, and for rarely being home. Okay, yeah, he did not actually die. I exaggerated. But the moral of the story is, if you are a kid, do not take medicine without parental supervision. But you're probably not a kid because you wouldn't be learning functions. But I don't know, maybe. So if you understood all of these examples I have given so far, you are good to go. If not, and you didn't understand 90% or 100%, I mean 100%, you should probably go for 100% of what I said in this video. I have some further resources you could use to understand functions and be able to solve problems with functions in them. These are these. They're all great. If you know a different resource that helped you in learning and understanding functions that isn't above, please share it in the chat for everyone who might be able to use that, who decides to read the chat. Even if it helped only one person, I think it is worth it, since it just takes 1 minute of your time. Thank you for watching this video. If you liked it, give it a like, and tell me how I could improve my videos to either make them more entertaining, fun, interesting, creative, understandable, or etc. If you thought this video was helpful and know someone who doesn't understand functions, be sure to share it with that person. Have a wonderful day and good luck. Oh, and stay happy and healthy and safe. Bye.